Algebra Lesson 1-1, Numerical Operations. Okay, when we're working with the FATDEC program, the FATDEC program refers to number systems as grouping numbers. So number systems, grouping numbers, these will be interchangeable. And we talk about the ways that the numbers are similar to each other or can be grouped together. So personally, I like to think of the number systems as families. There are two main families of numbers. There are the real numbers, and there are the complex numbers. Right now we'll be dealing with the real numbers. So when we start talking about numbers, we'll start with the smallest set of real numbers, which are the natural numbers. And these are also known as counting numbers, and that's because we count them. 1, 2, 3, 4, 5, 6. They're infinite, but they're infinite in only one direction. They do not include zero. They do not include negatives, no fractions, no decimals. And they are symbolized with a bold N. Then the next set of numbers, which the natural numbers, as you can see, fit inside of, are the whole numbers. And those include 0. And that's the only difference between natural numbers and whole numbers, is that whole numbers are all of the natural numbers plus 0. And they are symbolized with a bolded W. Now you can see the natural numbers fit inside the whole numbers, and the whole numbers fit inside the integers. And these are all of the whole numbers and their opposites. So we have all of the positive numbers and all of the negative numbers. Again, though, no fractions or decimals. And integers are symbolized with a bolded capital Z. The next set we have are the rational numbers. These are all of the integers, so everything here, natural numbers, whole numbers, integers, and all of the fractions and all decimals that terminate, so end, or repeat. And they're symbolized with a Q, bolded Q. Now the next set we have are the irrational numbers, and as you can see, these don't fit in with this set here. The irrational numbers are separate. So if we're talking about like a number family, this is Crazy Uncle Joe. So he's part of the family, but he doesn't really fit in. These are all of the decimals that never end and never repeat. Big famous example of that is pi. And we can say R minus Q or Q with a bar over it, which means not rational. And the R is for the real numbers, and that's all of these. So real numbers include natural, whole, integer, rational, and irrational. These are all real. Another way to look at it is that every number here is real. So it'll be either rational or irrational. If it's rational, we have numbers that can be written as a fraction. So this is fractions, integers, and ending or repeating decimals. If you're not rational, then you're irrational. And an irrational number is a non-repeating, non-ending decimal. So we have square roots of imperfect squares, cube roots of imperfect cubes, pi, numbers that go in what looks like it could be a pattern, but it's not exactly a pattern. So if you're irrational, that's where the line ends. You're just irrational. Now, if you're rational, you're either an integer or you're not. If you're not an integer, you're a fraction or a decimal, or you're an integer, which means you're a positive or negative whole number. If you're an integer, you're negative, or you're positive. If you're positive, you're a whole number. If you're a whole number, you're 0, or you're natural. So that's just another way to look at these. Okay, so when we look at this, we can categorize these. Now we go, okay, looking at this 17 under the square root. 17 is not a perfect square. That will make it irrational, but it will still be real. -2, this is a whole number, but it's negative. So it's not natural or whole, it's an integer. If it's an integer, it's rational and it's real. Here I have a fraction, a negative fraction, but it's still a fraction. That makes it rational and real. 0, 0 is a whole number, but it's not a counting number, so it's not natural. If it's a whole number, it's also an integer and a rational number, and it's real. -6.06, this decimal ends. That makes it rational. This decimal repeats, so that's also rational. Now here I have what looks like a pattern, but it goes 0, 5, 0, 0, 5, 0, 0, 0, 5. So it's a pattern, but it's not a repeating. So if it went 0, 5, 0, 5, 0, 5, it would be repeating, but this is not repeating, it's changing. That makes it irrational. 18, we can count to that, so it's natural, which makes it whole, integer, and rational. 43 divided by 0. You cannot divide by 0. Therefore, we are not real or defined. So it's none of them. Pi never ends and never repeats. Oops, that's not what I meant. Sorry about that. So it's irrational. Here I have 634 repeating, so it'll say 634, 634, 634, so that makes that rational and real. The square root of 225 is 15, so that's a counting number, so that's natural, whole, integer, rational, and real. 0.634 is an ending decimal, so that's rational. 4/49 square root. The square root of 4 is 2. The square root of 49 is 7. That's a fraction. That makes it rational. And then negative the square root of 84 is -8. So it's an integer and rational and real. Okay, so next we're going to go into integer concepts. So an integer is a number with no fractional part. It includes the counting numbers, 1, 2, and 3, etc., 0, and the negatives of the counting numbers. So -1, -2, -3, etc. We can write them together, and they can be graphed on a number line. A number line can be used to represent integers. As we move to the right, the numbers will get larger. As we move to the left, the numbers will get smaller. If we think about money, negative numbers can represent money that we owe, and positive numbers can represent money that we have. So that can help us with the concept -12 is less than -3. So even though 12 is greater than 3 if we're talking about positives, -12 is less than -3. If you owe $3, it's better than owing $12. So you actually have more money if you only owe $3. Okay, we can model with integers to help understand the operations on integers. So we have opposites, which we can use colored chips. You could use checkers, or you could get beans like kidney beans and pinto beans, or something, 2 different colors of beans, black and white, things like that. So we set one color to be negative and the other to be positive. So if I say that this is positive and this is negative, one positive and one negative will cancel each other out. So if I have one positive and one negative, I have 0. If I have a set of positives and negatives, I can cancel out all the matching pairs and count up what's left. So those cancel, 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 cancel. And I have 2 that didn't get canceled. So 2 negatives, which means I have a -2. I can also use pluses and minuses if the colored chips don't work. Maybe you only have a pencil with you and you don't have two different colors. So one plus and one minus will cancel each other out. So if we have a collection of pluses and minuses, matching pairs cancel each other and we can count up with. Okay, so I have all these pluses and minuses and I will cancel out one plus and one minus, and then another plus and minus, and another, and another, and another, and another, and another, and another, and another. And then I can count up how many pluses I have left. I have 5 pluses left, so that gives me positive 5 as my answer. And finally, we can use the number line, remembering that positive moves to the right and negative moves to the left. So positive to the right, negative to the left, and each number on the number line corresponds to a space. So I can count the number of spaces moving left or right that's equivalent to the integer that I'm representing. So for example, if I want to represent -3, I would start at 0 and move 3 spaces to the left. If I wanted to represent 7, I would start at 0 and move 7 spaces to the right because I'm talking about a positive. If I'm using the number line to see what we have left after I combine them, I start at the first and move that many spaces left or right. So first I go to -3, then I landed on -3 and I want to go to +7, but I don't want to go to +7, I want to move +7. So I have 1, 2, 3, 4, 5, 6, 7, and I land on +4. So -3 and +7 will give me a +4. So when we add integers, we can use the models that we just did. I can choose any one of the models, colored chips, pluses and minuses, or the number line, and I can use them to combine the integers being added, and that will help me to determine the answer. So I'm going to do 5 and -8 using all of the models. So first I have the chips. I'll have 5 positives and 8 negatives. Then I will cancel 1 positive and 1 negative, leaving me with 3 negatives. If I do pluses and minuses, I have 5 pluses and 8 minuses, and I cancel, which will leave me with 3 minuses. And if I do the number line, I'll start at +5 and move 8 spaces to the left and land on -3. Each result gives me -3. Here I have 3 negatives. Here I have 3 negatives, and here I land on -3. So you can use models to do adding integers if that's what works best for you. Or you can use the rules. And the rules are if the signs are the same, then you add the numbers and you keep the sign the same. So +8 and a +9 make a +17. A -7 and a -11, I add 7 and 11 is 18. They were both negative, so I keep it negative, -18. If the signs are different, I subtract the numbers and I keep the sign of the number that was bigger. -8 and 10, 10 minus 8 is 2. 10 was bigger and it's positive, so my answer is 2. 11 and -15, 15 minus 11 is 4, and the 15 was bigger and it's negative, so my answer is -4. If we think of it as money again, money I owe versus money I have, money I owe is negative, money I have is positive. So owing $10 is -10. Borrowing $15 is -15. -10 and -15, I owe 25, so -25. Okay, if I owe $12 and I earn 19, that would be -12 plus 19. I'd pay it back and have 7 left over, so +7. Okay, here are some example problems. 2 positives, add them together, gives me a positive answer. A negative and a positive, I subtract. The 27 is larger, which is positive, so I get a positive answer. 2 negatives, they're the same. I add them together and I get a negative answer. A positive and a negative, the positive is larger, so I subtract and I get a positive answer. Here's a positive and a the negative is larger. When I subtract, I will get a negative answer. And finally, negative 27 plus 6, negative 27 is larger, so I get a negative answer, 21. Subtraction is the opposite of the addition. So we're removing something instead of adding something. And the key word in that sentence is opposite. When we subtract, we perform the opposite operation. So we add the opposite. So the first step is we're going to convert the subtraction to addition. And then we'll follow the rules for addition. So 9 minus 5 is going to be 9 plus negative 5. 9 and negative 5 gives me a positive 4. Here, if I have 5 minus 15, that's the same thing as 5 plus negative 15. They're opposite signs, so I subtract. The 15 is larger and it's negative, so the answer is negative 10. Negative 3 and negative 12, negative 3 minus 12 is negative 3 plus negative 12. They're both negative, so I add them together and I get a negative 15. 6 minus negative 2 is the same thing as saying 6 plus 2. I'm adding the opposite. That gives me an 8. And negative 8 minus negative 3 is the same thing as negative 8 plus 3. So that's an opposite sign situation. So 8 minus 3 is 5. The 8 is larger, so the 5 is negative, negative 5. And here are some tricks to help you remember to turn the double negative into a positive. I've got 3 tricks. When you see that double negative, the first trick I have is that I make a smiley face. He's happy, which is positive. So 6 plus 5. You can connect the dots, and it's a giant plus. So 6 plus 5. And then some people like to strike them both. But you have to remember, if you're doing this strike them both thing, that has to be 2 negatives. No matter which tip you use, as long as you remember that that double negative becomes a positive. Okay, multiplying integers. You know that multiplication is repeated addition. We have rules for multiplication. If the signs are the same, we multiply the numbers and the answer is positive. So positive times a positive gives us a positive, and a negative times a negative gives us a positive. If the signs are different, we multiply the numbers and the answer is negative. Positive times negative is negative. Negative times positive is negative. It doesn't matter which one is bigger. It just matters if the signs match or not. So we can think of this as a game, a matching game. If the signs match, you win, and that's positive. And if the signs don't match, you lose, and that's negative. So here's some examples. Positive times a negative gives me a negative. Negative times negative will give me a positive. Positive times positive gives me a positive. Negative times positive gives me a negative. And if we're multiplying more than 2 numbers, you can either go through and multiply everything individually, or you can count up how many negative numbers there are. If there are an even number of negatives, the answer will be positive. If there are an odd number of negatives, the answer will be negative. So here's an example. When I count these, I have 1, 2, 3, 4. 4 negatives. That's even, so my answer will be positive. When I count these, I have 1, 2, 3. 3 negatives is odd, so the answer is negative. Here's how this works. When I multiply these two together, a negative times a negative gives me a positive, and a negative times a negative gives me a positive. So everything multiplied will then end up being positive because I have a positive and a positive. So I'm multiplying all positives. On the odd number of negatives, these give me a positive. So I have positive, 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 negative. And that one negative that's left over makes the whole answer negative. Dividing is the same rules. If the signs are the same, divide and the answer is positive. Negative divided by negative is positive. Positive divided by positive is positive. And if the signs are different, divide and the answer will be negative. Negative divided by positive or positive divided by negative give you a negative. Again, it doesn't matter which is bigger, only if the signs match or not. So think of it as a matching game, the same as multiplication. If the signs match, you win. If the signs don't match, you lose. Here are some examples. I have a positive divided by a negative. That gives me a negative. Two positives give me a positive. Two negatives give me a positive. And a negative divided by a positive gives me a negative. Next, we need to talk about the order of operations. An operation is a mathematical process. So adding, subtracting, multiplying, dividing, etc. So why a specific order? Well, math is universal, and the order of operations ensures that everybody in the world, if given the same problem, will perform it in the same way and come up with the same answer. So for example, we're going to have the right way and the wrong way. If I do this the right way, I'm going to follow the order of operations, which is going to give me 3 plus 50, which is going to give me 53. If I do this the wrong way, I'm just going to move across. I'm going to have 8 times 10, which is 80. So as you can see, I get two very different answers. That's why it's very important to do it the right way, so that you get the correct answer, the standard answer, the answer everybody else is going to get. So how do you remember that? Well, there's a phrase, PEMDAS. Well, I guess it's a word, made-up word, fake word, PEMDAS, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. First, you do the parentheses. Parentheses is actually all grouping symbols, not just parentheses. It can be parentheses, braces, brackets, absolute value bars, and fraction bars. So, fraction bar. You're going to perform all operations inside or on either side of the grouping symbol first. Then you do exponents. So after you've done all the parentheses, you calculate the exponents. Then you'll do multiplication or division in order as you move left to right across the problem. Left to right. Sorry about that. Did that backwards there too. So then you add or subtract in order as you move left to right across the problem. Other ways to remember, please excuse my dear Aunt Sally, PENDAS, or purple elephants munch daisies all Sunday. Okay, so let's look at another way. If you think of them, the operations as royal family, first you have parentheses. He's the king. So what he says or what he wants comes first. He's the king. He's in charge. Next we have the queen, and the queen is the exponents. So anything the queen wants comes next. Then you have the prince and the princess. That's multiplication or division. They have equal power. Then you have the peasants, which are addition or subtraction. Again, equal power, but all the peasants are equal below the prince and princess, who are equal below the queen, below the king. So, doing some of these, I have division and addition. Division comes first, then addition. So I'm going to do 72 divided by 9, which is going to give me 8, plus 7, which is going to give me 15. Here I have multiplication first, so that gives me 2 plus 35, which will give me 37. Addition and subtraction are equal, so I can just move straight across the problem. 9 plus 8 is 17, minus 7 is 10. I do the division first. 32 divided by 4 is 8. 9 minus 8 is 1. Parentheses. Parentheses come first, so I have to do that 10 minus 1 first. Then I can multiply. Parentheses first, before division. So 48 divided by 8 is 6. Now, when I have parentheses inside parentheses, I have to do this first and then this second. So I'll have 20 divided by 4 minus 10 minus 8 is 2. And that'll give me 20 divided by 2, which will give me 10. Here I have 40 divided by 4 minus 5 minus 3. This parenthesis has to happen. And once that's happened, the next thing that happens is division. So this will be first, this will be second. 10 minus 2 is 8. Now with a fraction bar, I have to do this first. So that will give me 27 over 5 plus 4 is 9. Then I do the division. 27 divided by 9 is 3, and then 3 plus 3 is 6. Here I have division and a parenthesis. I have to do this first. Now this is a division, but it's a grouping symbol, so I have to do that second. So 5 times 3 minus 13. Multiplication comes next, then subtraction. Parentheses first. So 10 plus 2 minus 2, that's 12 minus 2, which is 10. Then multiplication, then subtraction. If I have parentheses inside of brackets, I can do those at the same time, but I have to do them first. They come before the brackets. We work from the inside out. Okay, and then I write down everything else exactly as it is. So 3 minus 7 is negative 4. 4 minus 6 is negative 2. Exponents come next. Negative 2 squared is 4. Then I can do multiplication. Then I'm in brackets. So now I have to do the 16 plus 4, so that gives me 20. So that gives me 140. So what I do a lot of times is I'll do this to indicate that's the operation I did. Oops. That's minus. 9 minus 6 is 3. And then I'm going to square that. Negative 3 squared is 9. Then I do my multiplication. Then my subtraction inside the braces. Then my multiplication. So why don't you pause for a second and try these two, and then unpause and see if you get the same answer as I get. Yeah, go ahead and pause. Okay, so you should get 40 for number 3 and 465 for number 4, and I've written the steps out. So if you didn't get those answers, pause again and go through and look at the steps very carefully and see if you can find your mistake. If not, get in touch with me. If you have a question.